Good morning, one and all. This is Anu from PhD College of Arts and Science from the Department of Software Systems. Today, we are going to see a glimpse of the OSA model in the computer networks. So, before going to the OSA model, let us see a real-time scenario. Let us consider two persons, Maria and Anne. And Maria knows only Spanish, whereas Anne knows only English, and they have to communicate with each other some secret, some important thing, and it should not be seen by others. And they know only Spanish, and Maria knows only Spanish, and Anne knows only English. So it has to be translated, and this has to be communicated from Maria to Anne. This is the real time scenario. So what we have to do, we have to know other way. We have to uh, encrypt the code, and we have to translate it, and we have to transport to and uh, home, and it has to be again, the Spanish has to be translated to English, and it has to be decrypted in the receiving side, and then only and can understand the contents. This is how it can be done in real time scenario. Similar things happen in computer networks also, that is nodes. So this is done by the OSA model, that is open system interconnection. It consists of 7 layers, and the 7 layers are application, presentation, session, transport, network, data link, and physical. And it must be in this order only. In the source, it has to be communicated from application to physical, that is layer 7 to layer 1 is done in source side, and in the destination side it is vice versa, that is physical layer to application layer. That is how it is done in the thing. So how it can be exchanged? So let us consider device A is the source and device B is the destination, and we have n number of intermediate nodes, and this is how it is done. So in the device A, from layer 7, that is application to physical layer, it is interacting, and then into intermediate nodes it is interacting up to the network layer. In the network layer only decides whether it is a destination or not, and device B is the destination. So from layer 1 to layer 7 it goes up to device B. This is how it is done. So for how it is actually the exchange is happening is the thing. D is the nothing but the data. D7 is the application layer data, and some header is included here, and in each and every layer the header is included. So D6 is nothing but the D7 plus header, that is the previous whole data plus another one header is included. So in each and every layer header is included, and the last one, zeros and ones, is nothing but the bits. This is how the actual transmission takes place. It has to convert it to bits, and then only we can transmit in physical layer. That is the transmission media can be a wireless media or wired media, whatever be the thing, but it has to be converted like this only. And this is how it is done in the source side. And in the destination side, what happens is the header is removed accordingly, and only the data is given to the destination. So this is how the exchanges of happening in the OSA model. So let us consider a internet, that is A is the source and B is the destination, and we can go from A to B. We have n number of routes are there, that is A to R1, R1 to R2, R2 to B, and or R2 to R4, and then R4 to B, and it can be done as A to R1, R1 to R3, R3 to R4, and R4 to B. But what happens is it will be doing only the shortest path. So most probably it will pick from A to R1, R1 to R3, R3 to R4, and then to B. This is how it is done. So if it is a physical layer, then it will be only the physical layer will be contacting. So this is how it is done, and it will be only in the zeros ones. That is, here it is only going to be bits. And if it is a data link layer, here we will call it as a frames, and that is from A to that is data links. The source is a data link layer, the source is the A, and destination is the B. So in the source up to data link, in each of everything it will go up to the data link layer. And here we will call it as a frame, and here the data plus header will be given. And the next one is the network layer. So network layer, here in the same thing is consider. Here we will call it as a datagram if it is an UDP, and D3 and H3 combinedly we will call it as a that is data here, and combinedly we will call it as a datagram here. So for each and year source as well as destination as well as intermediate nodes, what it will happen, it will go up to the network layer. But as far as transport layer is and other layers is concerned, it will, for the intermediate nodes, it will not go above the network layer. This is what we have seen it here, and here we will call it as a segment. So D4 plus H4 combinedly we will call it as a segment. This is how it happens. Okay, and the summary of the, let us consider the functionalities of the OSA layers. Application layer deals with the how the network resource can be accessed, and in the presentation layer, in the source, it is translated, encrypted, and then the data is compressed. For example, the data is a movie or audio or video file, it is going to be a big thing, so it will be compressed. And in the session layer, the managing, establishing, managing, and terminating of sessions is done. In the transport layer, process to process message delivery and error recovery and direction is done. Process to process message delivery in the sense ports has to be taken care of. And in the network layer, the main thing is, we will call here, we will call it, the things are as the routing. That this is the main important thing. That is what is the shortest path from source to destination, we have to find it out. In the data link layer, we will call it as frames, and it will give you the, it will provide you the hop to hop delivery. In the physical layer, it will be converted to bits, and it is the main thing for the actual transmission of data. This is how it is done, for the actual transmission of data is done. Thanks a lot.